Welcome to another Intermediate Algebra video. Today we're going to be looking at linear inequalities. We're going to solve them, answer in interval notation, and also on a number line. So our objective, as I mentioned, solving linear inequalities, and then the three ways that we're going to answer. The notes for these types of problems, we will use the same steps as solving linear equations, with one exception, and that exception is this first bullet point right here. When you multiply or divide, I want to highlight that, multiply or divide both sides of the equation, or of the inequality, by a negative, then the symbol will flip directions. So these are the four types of symbols that we're going to see in this video. Less than, greater than, less than or equal to, and greater than or equal to. So if in our solving we multiply or divide by a negative, that symbol will flip directions. It's the only difference. So the inequalities we'll see are listed here. When we graph these on a number line, if we have an inequality symbol that does not include an equal sign, then our number line will have an open circle, and our interval notation will use parentheses. It's not necessarily the case that all of it would be parentheses. It could just be that part of it is, but an open circle goes with parentheses. If our inequality symbol included an equal sign, meaning the number is less than or equal to the variable, then we'll have a closed circle on the number line, signifying that it is included, as an equal sign suggests. And then interval notation will use brackets. Again, potentially not both sides having a bracket, maybe just one or the other, but we'll see that when we go through the examples. If we run into infinity on a number line that we're translating to interval notation, infinity will, for interval notation, we could have negative infinity, we could have positive infinity, and this is all for interval notation, not necessarily for a graph. On the graph, it'll just be shaded. That's why it's not part of the chart. But in interval notation, you'll see one of these two symbols and parentheses. The main difference between parentheses and this hard bracket is that parentheses signifies that we get really, really close to, but never touch that number. The bracket says we hit this number. This number itself is included. And that's why infinity always gets parentheses. We can never actually hit infinity. If you think you've hit the farthest number, go 10 further, there's another. And then just as a side note, you might see something like this in the homework system. I'm not going to ask for a solution in this format, but you might see it this way. An alternate type of solution looks like this. It's inside these curly brackets, and it's read as x such that x is less than 5. So we have x here, this brace, this little stick line means such that, and then the inequality itself. X is less than 5. So if you were to have to use this alternate type of solution in the homework system, the setup will always be there for you. You will literally just be plugging in the inequality solution. All right, so let's see some examples. The first one, solve. The directions say answer all three ways with the inequality symbol on the number line and in interval notation. So let's look at our general goal here. Our goal is to find all the x values that would make this a true statement. When we solve an equation, there's typically only going to be one solution. There's only one number that'll work, that'll give you a true statement. But with an inequality, there's a whole bunch of solutions that would work. Just looking at this inequality, you can recognize there's numbers you could plug in here easily that would work. If you plugged in 100, 2 times 100, definitely greater than 8. If you plug in 1,000, 2 times 1,000, definitely greater than 8. So how do you come up with all of those solutions? Well, first we'll solve and get kind of an inequality solution, and then we'll translate that a couple different ways. So to solve the inequality first, follow those equation solving steps. Distribute, can't distribute, combine like terms, nothing to combine, add, subtract things to both sides, and finally, multiply or divide. Undo the operations on the variable. We have multiplication, so we divide. Divide both sides by 2, and we get that x is greater than 4. So that's our first, I'll underline it, first of the 3 types of solutions. We have answered with the inequality symbol. So this more clearly tells us every number greater than 4 is a number that would make this initial inequality a true statement. Okay, so let's put that on a number line. Number line. I typically like to show where 0 is, and then the hotspot. I'll refer to the number with the inequality as the hotspot. So at this hotspot, as the chart from the previous slide said, because our symbol does not have an equal sign, we'll put an open circle at this location. I'll explain why in a moment. Okay, then we want to shade according to where all of our solutions are. So our inequality says that x is greater than 4. So we want to shade all the numbers that are greater than 4, which happens to be on the right. So this is the graphical, the number line solution for our inequality. This is another way of looking at the answer. Visually now we're seeing all of the numbers on the right side of 4, all of the numbers that are greater than 4 are the ones that work to make this a true inequality. The reason the 4 gets an open circle is because the location itself, 4, doesn't make this a true statement. Not x. Is 4 greater than 4? It's not greater than, it's greater than or equal to. So open circle tells us that spot itself is not included, but the moment right after, it's included. This is not true, but the next spot, 4.01, 4.00001, all of those would be included. So this is how we signify not this exact spot, but the very next moment is when it starts to work. Okay, and our last type of solution is interval notation. And interval notation is simply reading this number line like a book. It's just a third way of giving the solution. Interval notation. So that'll go up here. Okay, so looking at this line, where's the first place we see a solution? From left to right, read it like a book. No solution, nothing, nothing. The first place we see a solution is at 4. So we'll start with 4, put a comma, okay, where does that solution end? This solution goes on forever, so the solution ends at positive infinity. Now we have to decide how to put parentheses and brackets on this. The 4 is an open circle, it's not included, so it gets parentheses. Open circle and parentheses mean the same thing, get very, very close, but don't exactly touch it. And infinity always gets parentheses. You can't touch infinity. There's always a number further. So we have solution 1, 2, and 3. 3 different ways of referring to all the numbers that make this a true inequality. All right. Let's see another one. Second one, same type of problem. They all will be. Solve and answer all 3 ways. So if we follow those equation solving steps, first, distribute, nothing to distribute. Second, combine like terms. We have 2 x terms, combine them together. Negative x plus 3x is 2x. We have plus 4 less than or equal to 12. Then, add, subtract things to both sides, undo addition. So subtract. You might be wondering, okay, there's a negative happening to both sides of the inequality. Am I supposed to flip the inequality symbol? The answer is no, because the only time that you flip the direction of the symbol is if you're multiplying or dividing. Addition, subtraction has no bearing on it. All right, so we have 2x less than or equal to 8. Looks pretty similar to our last one at this stage. And then divide both sides by 2. Now we're dividing by a number, but we're not dividing by a negative, so still no inequality flips. We get x is less than or equal to 4. This is the first of our 3 ways of answering. This is solving and answering with the inequality symbol. Okay, the second way is on the number line. So it's just taking this solution. Our hotspot is 4. So at that location, we have a closed circle. Why a closed circle? Closed circle because our inequality says it's less than or equal to. That means the number 4 itself is a solution. 4 less than or equal to 4. That's true. So it should be part of the shaded answer. The shaded in circle tells you it's part of the solution. In this case, we want everything less than or equal to 4. So shade where all the numbers that are less than or equal to 4 are, which would be on the left side. So here's the second, our number line solution. And then the third is taking that and translating it to interval notation. So read this number line like a book. Where's the first place, starting from the left, that you see a solution? Well, right away we have a solution in negative infinity. Negative infinity is definitely less than or equal to 4. True statement. That's where it starts. Infinity always gets parentheses. We can't touch infinity. There's always a number further. That's where it starts. And where does our solution end? 4. And 4 gets the bracket because it's a closed circle. Closed circle signifies this is a solution. Bracket says this number is a solution. 4 is less than or equal to 4. That's true. So this interval notation solution, different way of presenting the same information. Between negative infinity up to and including 4, that's where all the numbers fall that make this a true inequality. 1, 2, 3 ways. You may not be asked on every question to give all 3 ways. In my opinion, it's very difficult to go from this first inequality solution straight to interval notation. I like the graph in between. So if you're only asked for interval notation, it's really up to you how you get through it. But I would encourage you to follow this route. You might only be asked for the graph, in which case you wouldn't have to go to interval notation. You might just be asked for the inequality. So follow whatever the directions say. All right, let's see another one. Let's answer all 3 ways for this problem. Again, first step, distribute. Can't do that. Combine like terms. There's nothing to combine on either side. Then add, subtract things to both sides. Get the variable by itself. Subtract 5 from both sides. We have negative x is less than 5. Then our last step, multiply or divide. Undo the operation on x. It's being multiplied by -1, so we divide by -1, and the alarm bell should be going off. We are dividing by a negative. This is the one and only reason that the inequality symbol will flip directions. Nothing else changes. You multiply or divide as normal. It's just the symbol that changes directions. So negative divided by negative gives us positive. 5 divided by -1 gives us -5. So we know the numbers that would make this a true inequality, a true statement, are all the values that are greater than -5. Here's the first of our 3 types. Second, the number line. We have 0 and 1, 2, 3, 4. Here's -5. At this spot, it's an open circle because our symbol doesn't have the equal sign, which means this number itself is not part of the answer. And then we want everything greater than -5. Greater than on the right. And then interval notation is just translating this. The first place we see a solution from left to right, starting from the left, is -5. That number itself is not included, so parentheses, get very, very close, but don't include it, all the way up to positive infinity. So this is the interval notation version of this solution. Okay, I think I have one more. Good. All right, same thing, solve, answer all three ways. And then there'll be some practice problems. First step, distribute. Distribute the negative, so we have negative x plus 3 plus 2 less than or equal to. Distribute this 3, 6x minus 15 plus x. Okay, combine like terms on each side. Negative x plus 5, 3 and 2 combine. On the right, 6x and x combine. 7x minus 15. Now add, subtract things to both sides. The goal is to get the variable on one side, numbers on the other. In this case, the truth is there's 4 good ways to start this problem. I'm going to choose to add x to both sides. If you chose to subtract 7x, add 15, or subtract 5 from both sides, all of those are perfectly fine first steps here. Whatever you did first, the rest would follow, and your solution will still look the same or very similar to mine, but I'll point out in what way it would be different. All right, so that's gone. We have 5 is less than or equal to 8x minus 15, and add 15 to both sides. We have 20 is less than or equal to 8x. Then divide both sides by 8. Now, if you started a different way, you might have the variable on the opposite side, and you might have a negative. So only if you have a negative are you flipping the inequality symbol. Mine does not, so I'm not flipping. Okay, so on the left, 20 over 8, we don't get a whole number. That's okay. If you put a decimal for this one, it would be okay. The fractions for this one, since the decimal is a clean number, there's no rounding involved, it would be okay. Or you could also go with the simplified fraction of 10/4. Oh, not even 10/4. 5/2. Pencil. Either one's okay. So this is one way to write it. Now you may have also solved and come up with, if you had the variable on the left-hand side, kind of the reversed, a mirror image of the solution that I got. But it still says the same thing. The version I came up with says 2.5 is less than or equal to x, which means x is bigger than 2.5 or equal to. The second way kind of clearly states x is larger than, greater than, or equal to 2.5. So either of these would be okay. More typically, an online homework system is going to give you a solution looking like this, but on a written test, either one is absolutely fine. So they're both good. Okay, the number line answer for this one. And the number line is really where the decimal is easier to look at. I can put 2.5, if this is 2 and this is 3, pretty clearly and easily without looking at 5/2. Either one's okay though. So at this location, it's a closed circle, because I have the equal sign involved. And you might be wondering, okay, well, how do I know which direction to follow? Which arrow do I follow? And can I follow an arrow? The answer is yes if the variable's on the left-hand side. You can follow the direction of the arrow for shading only if the variable's on the left and only if there's one inequality. If it's a compound, which you'll see in another video, it wouldn't work. So just make sure that you're reading what the answer says. 2.5 is less than or equal to x. Try to read from the variable. This means x has to be bigger than 2.5, or clearly here, x is greater than or equal to 2.5. So everything on this side. The shading solution should not look different. And then interval notation, from left to right, the first place we see a solution is 2.5. We get a bracket because it's a closed circle. This number does make this a true statement, all the way up to infinity. And infinity always gets parentheses. So we have the first way, the second, and third. All three types of solutions. All three representing the same information in different formats. Okay, some practice problems. Pause the video, go through these three problems on your own. Please note that the number 1, number 2, number 3, those are the problem numbers. Sometimes I have students use them as a decimal. They're just to notate what the problem number is. Pause the video, go through these. We'll go through them in a moment. Okay. All right, let's take a look at what these solutions are. Our first problem, no distributing, but we can combine like terms. We have negative x plus x cancels, 18 minus 2, 16. Divide both sides by negative 4. The alarm bell should be going off. You're dividing by a negative. That means flip the direction of the symbol. First way. Second way on the number line, 1, 2, 3, 4. We have a closed circle. We want everything less than or equal to. And then interval notation starts at negative infinity, which gets parentheses in all cases, goes all the way up to negative 4. Bracket because of our closed circle. So this is what you should have for the first one. Okay. And then our other two. Number 2, divide both sides by negative 3. Again, the alarm bell should be going off. You're dividing by a negative, so flip the direction. We get x is greater than negative 3. The number line. Open circle at negative 3, and we want everything greater, so we're shading to the right. If you did not do these problems on your own, you might be thinking, wow, she's going really fast through these. Yes, you are supposed to have practiced them. If you did not, I'm going to go through these problems faster. This is a review of these problems, so you really should just be checking your work at this point. Okay, and then interval notation. Translate this from left to right. The first place we see a solution is negative 3. Parentheses because it's open circle, because this number would not make it a true statement, all the way to infinity. All three. And then number 3, distribute 3x minus 15. Distribute the 2, 4x minus 2. Subtract 4x from both sides. If you want a different route, that's okay. Your final answer will still look the same as mine. Add 15. And then divide both sides by negative. Dividing by negative, ding, 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 ding. Flip the symbol. There's our first. Our second on the number line. Open circle and shading to the right. And then interval notation, same as the last one. Negative 3 to infinity. Good. All three types of solutions. So this video didn't have a lot of different types of problems. It was all the same type of practice for each problem. Solve the inequality, answer in these three formats with the inequality symbol on the number line and in interval notation. But this is a stepping stone for where we're going in the next video, which is going to look at compound inequalities. So good luck with all the homework. If you have questions, feel free to email me, and I look forward to seeing you soon.